Hi guys, welcome back to the shop. You ever have one of those projects that you thought you could knock out in one afternoon and 5 days later you finally finished it? So this is just a simple tool holder modification. Put in the dovetail cut so that it'll fit on directly on a tool holder. It's an AXA tool holder. Add a height adjusting stud and a couple of nuts, and also cut the back end off because it was quite a bit longer. So yeah, this actually turned out to be quite the project. So let's go ahead and jump right into it. Well, I hope this isn't blasphemy, but I'm going to attempt to modify this tool holder. I really like these CCMT inserts. These are the little guys, they're the size 2.5. And I have two different profiles. This one's for aluminum, this one's for steel. So it'd be nice to have two tool holders so I can just switch back and forth and not have to change the inserts. I picked this one up on eBay, dirt cheap. I think it's because it's a 1-inch shank with a small insert size, so nobody really wanted it. It's brand new, never been used. As compared to, like the standard 1/2-inch or 5/8 inch shank, these go for a lot more money because they're more popular. I also picked up one of these guys. So this takes the same insert, but it uses the side edge that you normally don't use. And this is just an import Chinese one. I just wanted to try one. We'll see how it works. I mean, it was really low cost on Amazon. I looked at buying the US version of this, and oh man, I mean, we're talking over $100 for one of these. But if it turns out that I like this and I use it, it might be worth just getting the good version. But we'll try this one first. So yeah, so I got to cut this out. And this has got to be some tough material. I'm sure it's a high quality alloy steel, and it's way longer than I need, so I'm going to cut it off. But before I do that, I'm going to do some testing on this side, and then we've got to put in the elevation screw. I'm a little worried because this is thinner than your typical AXA. And by the way, the 1-inch is perfect for AXA. It's the exact same width, okay? So I may just turn down a shank on here and just press it in so I remove less material because, I mean, obviously it's going to weaken it a little bit. Whether it's enough to bother it or not, I don't know. But anyways, that's the plan. I just made a test cut just to see what we're dealing with here. So I got a 3-flute carbide end mill, a nice stubby one, 210 RPM with a 10,000th depth of cut, and it was pretty tough. So I'm going to try a 20,000th depth of cut, see how that goes. Okay, I took a close look at our end mill. It seems to be holding up pretty good. It is tough going, so we're going to stick with this 20,000th depth of cut, but we're going to move over and start hogging out. All right, I'm just going to keep chipping away. We're at 140 thousandths. Our end mill's still hanging in there. Let's keep going. We're about a third of the way there. carbide cutter took a little bit of a beating. Not terrible, but not good either. This is going to be my first ever use of the Randy Richard dovetail cutter. I've had this for quite a while, never had a reason to use it. So after seeing how difficult this material was to mill with the carbide end mill, I used the phone a friend option. I gave Randy a call and I was asking him about, cutting speed and depth of cut and that and so forth. And we talked about this material, and he had a good idea, and I think I'm going to go that way. He suggested trying to draw back the hardness a little bit on this tool holder. I don't have a regular heat treat oven, but I do have a toaster oven that'll go to 500 degrees. So I'm going to look up and see what that will do. I think if I give it a pretty long soak and then a slow cool down, that might take some of the hardness out and make life a little easier. I hate to lose the bluing, but I can always reblue it with cold blue. So let me do a little bit of thinking and see which way we're going to go here. That's weird that they put a sticker over that. Huh. Well, here goes nothing. I'm just going to do this in the toaster oven. I got it cranked up as high as it'll go, and got it out here in the sun to try to give it a little extra boost. It's the next day, so I had my little toaster oven set as high as it would go, and I always thought that it maxed out somewhere around 450, but looking at the color that we got and checking our chart in our engineer's black book, let's see, light purple. I'm going to call that maybe light purple or maybe dark purple. So according to that, we got up to 550 or 288 Celsius. And I let it soak for about an hour and a half at that temperature, and then I just slowly backed it off over about another hour, going down to like 100 degrees each time. So yeah, it's really surprising. It didn't burn the bluing off. I thought it would burn that right off, but that held up as well. So I don't know how much that drew it back, if we reduced the hardness any, but heck, it was worth a try. All right, so time to set up for the dovetail cutter. Okay, now we're going to touch off on the right side. We're going to start out with some really light cuts. We're going to go 5/1000ths on our first pass here. See what happens. All right, well that was uneventful. Let's take another 5. All right, let's try 10. We're running 1100 RPM. That's about what Randy recommended we run. All right, let me take a look at how we're doing. Looks pretty good. We're going to keep going. Well, you can tell by the sound we're getting deeper into the cut. So I've reduced our depth of cut to 5/1000ths per pass. And I just checked the insert, it's still looking pretty good. Well, all right, so rotating that insert really helped. I mean, it's still tough going, but it definitely, we had lost the edge, even though it looked fine under magnification, but it definitely was not cutting to its optimum. So we're pretty close now, so what I'm going to do is switch over to this side, and when we get both sides looking about the same, we'll start taking some measurements with some pins. Okay, you're the watcher this time, you're the cranker, okay? And I'm the squirter, okay? Alright, let's go. That's a good speed. Alright, you're doing good. Nice and steady. See what it's doing? It's making a V. Called a dovetail. Not too fast, nice and steady. Okay, now come all the way back. You go a little bit faster coming back. Okay, a little bit more back. Okay, good. Okay, now we're going to dial in a little 5. Okay, now it's Ethan's turn. You got to switch. Yeah. Go nice and other way. Nice and steady. Nice and steady. There you go. It's going to start cutting in a minute. There we go. You can use 2 hands. You can put 1 hand on there. There you go. Not too fast. Nice and steady. There you go. That's looking good. A little faster. Just go a little bit faster. A little bit faster. Nice and steady. Now you can come backwards. Just back a little bit faster. Backstroke. Another one? Or you want Dylan to do another one? Okay, back up a little bit. Okay, let me dial it a little more to the cut. Okay, go not so fast. Nice and steady. go a little bit more. This way. Keep going for a little bit more. All right, then we're going to take a look and see how we're doing, okay?
And then we might do some more?
Yeah. Okay, we're going to clean up and measure. All right, guys, we got a long way to go. We got to go to roughly an inch. So that's what, about 175, a little more, thousandths to go. So I was a little conservative when we hogged out our slot, our initial slot. So I think what I'm going to do is go back and set up an end mill and take a little more out of these corners. That should speed things up so we don't have to do so much heavy cutting with the dovetail cutter. So, okay, change of plans again. I decided I'm going to shift our cut over slightly, just to give the tool a little more offset in this direction. Okay, so that's what we're going to do. And just a little sanity check. Okay, that looks good. I switched over to the larger cutter. So far it's handling it pretty good. So I'm taking 5 thousandths per pass, and we're running at 660 RPM, a little slower than the other cutter. All right, let's take a pass. Okay, it's just going to be a lot of light cuts. I'm just going to keep on going here. Well, let's measure it and see how we did. We need to go to 1 inch and 5 thousandths. So we're 10 thousandths short. Okay. And then I was looking at our relief cuts here. So we're going to take it from the same side that we're working on right now. Well, we're shooting for 1 and 5 thousandths. That's pretty good. I'll take that. We ended up with 383 on our depth, and we were shooting for about 380, so a little bit deeper, but that's just a clearance, so it really won't make any difference. Well, I guess it's time to see if it actually fits on the tool post. All right, I'm handheld with the iPhone here. Nice. Not much play. Okay. All right, I like it. Okay. Now I got to decide whether I want to try to put the height adjustment stud in there. Okay. Oh, and we got to cut this off also. I'm just gonna do that in the abrasive chop saw. All right, now I would like to put in a stud for the height adjustment. Okay. Now there's no way I'm going to be able to drill and tap that. So what I'm thinking is just drilling a hole. I'm going to have to use carbide. I do have a couple of these 3 flute. I don't know, can you guys see that? That's I believe that's a center cutting, and it's got a slight tip radius. So that's solid carbide. So if I can just drill maybe 3/8 depth, and depending on what this ends up drilling at, we can turn this down and do a little press fit. And I think that'll work, okay? I'm gonna try a test hole first, and this is just some cold roll piece of scrap, just to make sure that that is a center cutting end mill. It looks like it is. Okay, that worked. Just did a little test drill with our carbide end mill, and it works pretty good, so I'm going to go ahead and set up. Well, that actually drilled a lot easier than what I was expecting. So, but I'm not going to try to tap it. That's just going to be pushing the envelope. All right, so before we work on the stud, I'm going to cut this to length, cut off the excess, and I'm just going to do that off camera with the abrasive chop saw. So let me go do that. This one has a relief cut at the top, so I got to make sure that I'm not into that also. Let's give it a shot. Did a little off-camera deburring. That turned out halfway decent. Okay, this is a 256 thousandths gauge pin. There we go. Okay. I want to turn down the end of our stud here so we have about a 1/2 thousandths press fit. Okay, I got our stud turned down and I also shortened it a little bit. I had to shut the camera off. It was just getting too nerve-wracking. I'm still trying to get the hang of that DRO on the new lathe and how the dials respond and everything else. So yeah, I had to shut off the camera. But let's check our gauge pin. So our gauge pin is 256. Okay, and then we'll check this guy. And we've got 256.5. So hopefully that'll give us enough press fit. So let's go to the press. Okay, I'm glad I put that Loctite on there. That was not that tight of a press. We got to make this this knurled nut, and I've got a piece of scrap. It should work out nicely. We'll just do a skim pass just to clean it up, and then we'll knurl it, drill and tap, and then part it off. A little bit of chatter. It's all right, we're gonna knurl it anyways. Got a question for anybody else that has one of these Oloris knurling fixtures. Are you supposed to just let it float on the tool post? Because it's really hard to center it otherwise. It kind of makes sense to me that you wouldn't want to lock it all the way down. Maybe just a little bit of pressure on it so that it can find its own center. I'm going to try that. All right, let's slow our speed down. Okay, we got our adjusting nut made, and we also thinned down this regular nut a little bit so it doesn't look so overwhelming. Yeah, so this is looking good. I can't believe how much work it's been just to build this little tool holder. Man, oh man. All right, so last thing I'm going to do, I'm going to do it tomorrow. I'm done for today. I'm going to come in and cold blue everywhere that we machine, including the back here. That way it'll look like a factory deal, okay? And then we'll give it a try. pretty tough stuff. All right, let's take 10 thousandths cut. Squeaking a little bit. Give it a little oil. Okay, we're going to try a piece of DOM tubing. That stainless steel was a little too tough for that insert geometry. At least that's what I'm thinking. Alright, let's take 10 thou just like before. We'll let it keep going. There'll be 20 thousandths when we get to the end here. A little rough, but not bad. Okay, we're going to try a different insert. That first one was terrible. Here we go. Thousandths. So far, much better. $20. There we go. Much better, except for this chip. Okay, I like that. All right, let's head back to the bench and wrap this up. Well, guys, I'm going to call this a partial success. We did have trouble with the insert. We finally got an insert that's working much better, and we still need to do more test cutting to optimize feeds and speeds and such. But we've got a little problem with our stud here. I don't know if you can see or not, but it's starting to back out of the press fit. So we're going to have to redo that. I think there's enough length on here that I could just return that and not have to make a whole new stud. So we'll do that. We won't film that. We'll just do it. So yeah, a little bit of frustration, and I don't know if I would do this again or not. I think you're probably better off just buying a tool holder, the right size insert tool holder, and just going that way. I mean, the amount of time it took to do this, and still don't have it 100%. I don't think you're saving anything. But anyways, it was interesting to try it, and this will be usable. It's just going to take a little more effort. So anyways, that's what it is. So thanks everybody for stopping by, and we will see you on the next one.